In this example, we will demonstrate how to graph the polar equation r equals 1 plus 3 times cosine of theta. In order to do that, I'm going to create a t-table of values of theta in order to get values of r to represent on this graph. The values of theta that I will choose, at least at the beginning, are 0, pi halves, pi, 3 pi halves, and 2 pi, which I choose because those are relatively convenient angle measures to work with when involving a function such as cosine. If I plug these angle measures in for my equation, wherever I see theta, if I plug in 0, I will get 1 plus 3 cosine of 0, which cosine of 0 is 1, so this is 1 plus 3, which is 4 overall. If I plug in pi over 2, I'll have 1 plus 3 cosine of pi over 2. Cosine of pi over 2 is 0, so 3 times 0 is 0, and 1 plus 0 is 1. If I plug in pi, I will have 1 plus 3 cosine of pi, which cosine of pi is negative 1. So that will be 1 minus 3, which is negative 2. If I plug in 3 pi halves, it gives me 1 plus 3 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0, so that's 1 plus 0 again, giving me 1. And then 2 pi, 1 plus 3 cosine of 2 pi is equal to 1 plus cosine of 2 pi is 1, so that is now overall 1 plus 3, or 4 again. If I try to plot these points on my coordinate plane, starting with theta of 0, that means face towards theta of 0, or a radian measure of 0, and walk a distance of 4 in that direction, which puts us about here. That's my first point. My second point is at pi halves, comma 1. That means that we are now facing towards pi halves, and we are walking a distance of 1 in that direction. Puts me here. That is my second point. My third point is face towards pi in my direction, and the distance I travel is negative 2. If I'm facing towards pi and my distance is negative 2, I'm going to walk backwards a distance of 2, which will put me right here for my third point. So I've walked actually towards where 0 was for 0 radians. Careful what negative radius means. With 3 pi over 2, I will face towards 3 pi over 2 and walk a distance of 1 in that direction. That is my fourth point. And then my last point at 2 pi and 4, that means face towards 2 pi, walk a distance of 4, which puts me right back to where I started. Now, just from these points, it's not obvious what's happening, as I'm not sure how I connect these. Does it just look like this weird triangle handkerchief kind of shape? Am I rotating to 2 and then back to 3 and back to 4 and doing something like this, kind of like a bean or something? We're not exactly sure. So if you're not sure what is happening, it is always recommended to test other values. For example, let's say I want to test what is happening. I can maybe understand what's happening between 1 and 2, as that looks kind of typical of curve up to 2. But if I'm not sure what's happening between, say, point 2 and point 3, then let's test a value between point 2 and point 3. That is where I plugged in pi halves and pi, so let's try testing something like, I don't know, 2 pi over 3. That's between pi over 2 and pi. That will give me 1 plus 3 cosine of 2 pi over 3. I chose that number in particular because that makes the calculation a little bit easier, as cosine of 2 pi over 3 is just negative 1/2. So that'll be 1 minus 3 over 2, or negative 0.5. Which means between point 2 and point 3, I'm going to hit another point that I can find by facing towards 2 pi over 3 and walking backwards from that direction, which would actually put me down here in what would be quadrant 4 of the unit circle. That's because my radius is negative there. So then that seems that I'm getting more of an understanding about what is happening between point 2 and 3 if I am coming down to this point and then going to the point I have labeled as 3. So I can maybe try to connect those like this. Looks a little bit like a spiral. Now, I can do the same thing if I were to maybe test if I don't know what's happening between points 3 and 4, which on my table here, that's pi and 3 pi over 2. We could test another point like 4 pi over 3. That's between pi and 3 pi over 2. If I do that, 1 plus 3 cosine of 4 pi over 3, this is going to give you the same thing. 1 minus 3 over 2 is negative 0.5. Well, 4 pi thirds negative 0.5 means face towards 4 pi thirds and walk backwards an amount of 0.5, which would put us up here in what would be quadrant 1 of the unit circle. So that means after point 3, it seems like my pen wants to curve up to this point here then. So I'm curving up to there, and I'm starting to see a little bit of symmetry with what I've already drawn. And from there, I should be connecting to point 4. After this, again, I can use symmetry for this. It looks like I have symmetry across this x-axis here. Or you could test more points if you would like between point 4 and point 5. But what this is going to do is curve back out, back to where we started. So we have a figure here that seems to have an inside loop in on itself. This is going to be a special type of graph that is going to be known as a limacon. One thing I do want to point out about this limacon, though, before I finish up, is that I am going to have a point at the origin, or at the pole on the polar axis. The reason for this is because I know that there should be an angle measure for this function where the radius would be 0. The reason that I know that that is true is that I could even test this. Try taking this equation and plugging in 0 for the radius and see if there would be a valid value for theta. If I plug in 0 equals 1 plus 3 cosine of theta, and I can solve for cosine of theta by subtracting 1 and dividing by 3, I will get negative 1/3 is equal to cosine of theta. Now I know, even before I solve for theta, that that's going to exist because that ratio, negative 1/3, is between negative 1 and 1, which means that it exists within the range of cosine of theta. Or, if you apply arc cosine to find theta, negative 1/3 exists within the domain of arc cosine. If I do happen to use arc cosine to solve this, by the way, theta would equal arc cosine of negative 1/3, which I can use a calculator to approximate. Make sure that we are in radian mode here. Arc cosine of negative 1/3, which will give me an angle measure between pi halves and pi, comes out as 1.91 radians. 1.91 radians, well, that is less than 3.14 radians, and it's more than 1.57 radians. So that means it's between pi halves and pi. Somewhere in there's around 1.9 radians, which would maybe be about here-ish. At around that angle measure, I hit with a radius of 0, or I achieve a radius of 0. All that is really to say is that means I know I'm going through the origin. That the origin, or the pole, is going to be an included point on this graph. And it would also go through the pole again at 2 pi minus arc cosine of negative 1 over 3, which would end up down here in quadrant 4, or 3 rather. So it is going to happen to go through the pole, and you can calculate where that's going to happen. But just knowing that means that I should be including the pole as one of my points to intersect and go through. That's an important understanding for this limacon here, which is why we do not draw it to look like this or anything, like the bean shape. This should have a curve through the pole and back through the pole to create this inside loop.